Welcome everyone. Today I'm here with Jan Skalla, my colleague, system architect at Zerops, and we are going to discuss why many modern platforms they become, I would say, limiting as soon as an application gets just slightly more complex, and it will. We'll also discuss how an AI agent managed to build conformant Kubernetes distribution on Zerops, and also what this experiment teaches us about infrastructure for coding agents, which is, let's say, that hot topic now in tech. So let's start with a problem that almost every developer has experienced. But before that, Jan, please introduce yourself.
Okay, hello everybody. I'm Jan Skalla. I come from Czech Republic, Prague. I've been working in the data center and managed services business for like 10 years, working for fintech companies and so on, mostly out of MasterDC, which is my previous employer, one of the largest Central European data center providers. And I've changed my job for Zerops this year because I want to build something cooler, basically. And that's why I'm here. And I'm helping the guys push the platform to its absolute limits.
I joined Zerops at the end of January, so I don't know each colleague for how long they have been staying. You're still quite close, I would say. Not so long. I'm glad. Thanks for being here, of course, today. We are here to talk about why modern platform they might become, I would say, limiting, because many developers, they choose a platform because it makes the first deployment very simple. They want the thing to be in production as soon as possible. But then when the application grows, we start to have some problems. So they discovered that, for example, that they cannot run multiple processes. Maybe they want to install a dependency, maybe FFmpeg, cron, maybe they want to put SSH into the environment. Maybe they want to investigate why their application is broken. So why all these limitations?
Basically, it's because it is simple to build and it's simple to maintain, and it is simple to provide as an option and to do it fast with high density. So it's the easy engineering choice into how to build a platform. Basically, you can imagine it as a Kubernetes. If you have an internal developer platform inside your corporation or anything, it's mostly built on Kubernetes because it's already there, it's already built. So just take it, you put the pieces together, and you provide the developers with golden paths and nothing else. Because if you have only golden paths to take care of, nothing can get broken you didn't expect to get broken. So that's why many platforms, and rightly so, I would say, choose the path of only the golden paths. But if you want something else than what they destined you for on the platform, you must swap at that moment the platform completely, because it doesn't provide you any breadth, any width of possibilities. So you are faced with migration. This is what Zerops tries to prevent. We provide the basic opinionated golden path for you. That's the easiest way to go in. Just deploy the app as you would on Vercel or Heroku and start doing things. But then when you hit the limitations of the golden path, you can stray off it.
Thank you, Jan. And I think you are the perfect person to ask this question too, which is what is structurally different about Zerops? What is you think, like something that makes Zerops unique and different from most of the platforms, all the platforms? Because I also had this feeling, but of course I've been working more on the real part, but I would like to go into the even a bit more technical details. I'm very curious about this.
Most platforms, to achieve the density they need for their business to work, for the prices they offer, they choose either full app containerization, so Docker, Containerd, Runc, Kubernetes, something like this. Or they use a micro VM approach with Firecracker or maybe something else, where they use unique kernels, which again tie you down, so that they have very small footprint in the system and they can run a lot of workloads within one system. So that's how they achieve the density, but that's how they lose the ability to do a lot of things inside. What we chose instead is Linux system containers, LXC, which is older technology than Docker, but still developed, still very widely used, very stable. And it still achieves almost the same level of density you would get out of Docker. But instead of you having the entry point, the one application that's running as the primary inside the container being a single process, whatever that may be, whatever you push there, you get basically a full kernel inside. So the PID1 is the kernel. So you still share it with the host. So it's not like everyone can have their own kernel inside. So it's not a micro VM or full VM, but you can do whatever you want inside it as you would in basically any kind of Linux box, while we still get the benefit of density.
Yes, thank you. And quick story is that when I got proposed to join Zerops, I started to learn more about Zerops. And when I stumbled on the LXC, like Linux containers, I said, okay, this is interesting because I come from the DevOps background. I've been a Docker captain for a while, probably because I suck at CSS. But let's say I've always been more on the DevOps side more than the SS, I think. This is super fascinating if you understand this architecture. And thank you, Jan. And I would say when Zerops talks about the system containers, right, instead of app containers, what does that mean, let's say, for a normal developer? Like, can we try to explain this to the average developer?
Simply put, the highest impact on your workflow is that you can build anything within it you would be able to build like on your laptop with Linux. So you get apt, you get cron, you get multiple processes, you can get systemd for keeping things up, restarting them, or you can swap systemd for supervised D if that's what you prefer. So basically you get the ability to shape the system your application exists in. And you still get the advantage of containers. So it's lightweight, it doesn't use much resources. If you don't put a lot of other stuff into it, you're basically just using the same amount of resources for your application, let's say Node.js or Rust or something like that, that's running inside it, and that's what you're paying for. So the kernel, since it's shared, that's not something you would pay for. That's on the platform side. So it's only your application or your site applications within it. And the main difference when you build services with it is that you don't have to put every single little thing into a new site container or a new deployment. So it doesn't get really messy. You can build one image and it has all that you need contained within it.
Yes, so let's say that this is better when you have more containers, which is usually all the applications that are in production. Basically, all the applications that are in production, they are like that, of course, because of the complexity. Yes, thank you. How does the project level isolation model affect what developers are allowed to do?
Okay, so first I should get into what a project level isolation and Zerops means. It means that every single project you create has its own L2 segment of network, which is based on VXLAN. So you have a network level isolation between your projects. So you cannot see from one project within the other in any other way than through a basically public endpoints. So that's how you protect your projects from influencing one another. But what it gets you inside the project is that you have full visibility between all the containers, all the runtimes you can have there, between the databases that you might want to deploy. And we can allow you safety and protection within the system because we have load balancer and firewall in front of this private network that you have. So you don't have to care about that. You don't have to manage load balancer, manage firewall, which can get kind of complicated. So you can just define it in your Zerops YAML, and you'll have a specific port open, or you'll have a specific application path leading to a specific container. Just like that, you take care of that.
I read that the Zerops uses a VM layer. So what is this VM virtual machine layer, and what role does the VM layer play in Zerops?
So VM layer in Zerops is there to allow the developer more width of experience, so that there are things that you cannot achieve within LXC. For example, if you want to use specific kernel modules or eBPF, for example, to monitor your stuff and to get very precise and fast metrics, or you want to compile your own kernel or you want to run a complete Docker system with Docker Compose and stuff like that, which you wouldn't be able in LXC. So if you have these uses, you can just spawn a VM instead of Linux container. You, of course, lose some of the advantages of the density. So it generally consumes far more resources because you have to pay for the kernel you have just for you. But it, again, gives you more isolation. So if you've got an application where you, for example, need to encrypt your memory, that's the layer where you can do it. Whereas in the Linux container, you wouldn't be able to.
I have one follow-up question, which is, which platform do you consider the closest to Zerops from a technical point of view, from what you know, of course?
I mean, there are like 2 points of view I could take on this question. The first being what you are technically as a user allowed to do within. And in that case, I would probably say Fly.io, because you get micro VMs inside Firecracker there, and you can do basically most of the stuff you can do in a full VM there. And so you can do whatever you want, but you still have the density, you still have the automation, the platform around it, and so on. And from the like infrastructure level, like how the components are built inside, that's harder to answer. I would say I don't think I know a platform that's built very closely to how Zerops is built. Mainly, that's because, as we've mentioned before, all of the platforms or most of the platforms are built either on Firecracker or on Docker based or app-based containerization. So I'll have to look out for one like that.
To be honest, I also wanted an answer because it's an answer which is also for me hard to give, because it feels like a unique architecture, very fascinating, and this is also why I'm here. So that's it. It's like Rust, when I see something which is unique. This gets me curious. I don't know you, but I got like super curious when I heard this. And so the difference is not simply that Zerops has a longer feature list. We will also mention some of them, but the real difference is where the platform draws the isolation boundary and how much of the underlying Linux environment remains available to the developer, right? And now the Kubernetes part. This will be very interesting because most of the platforms, they work on top of Kubernetes, or they offer Kubernetes. We've been hearing for Kubernetes. Probably you have heard about Kubernetes for a while. And something which is a bit crazy about Zerops is that it doesn't use Kubernetes. It's not built on Kubernetes. In fact, the platform made this deliberate architectural crazy decision to use system containers instead of a platform like Kubernetes. But an AI agent managed to build a conformant Kubernetes distribution on top of Zerops. This is super fascinating. So Jan, before we discuss all these AI part, what happened? What did we build?
Okay, so basically, as a demonstration, I wanted to prove that the platform can handle almost any kind of workload, almost like an AWS could. So I've decided to go for building Kubernetes the hard way. So I haven't used any operator, I haven't used any Ansible like Kubespray or anything like that. So it is built completely component by component the hard way, as you would build it basically on a bare metal level. So I knew that I had the L2 VXLAN network, so I could rely on that in networking. And that's what basically had driven the shape of the deployment. So it is exactly the same as you would build it on dedicated servers within a data center that just provides you the L2 segment that you have. You have no public IPs to load balance or anything like that. That's what the Zerops load balancer does in front of it. So I've built 3 profiles as a recipe. Recipes in Zerops are basically opinionated ways of how to deploy shapes. Shape can be a runtime application, it can be a database, it can be basically anything that we've pre-built for the users to deploy on one click, basically. This uses GitHub and GitHub Actions, but it can be, of course, rewritten into basically any CI/CD. And what it does, that it starts with empty project and it creates Docker VMs, because you need, of course, some runtime, so this cannot be run inside the LXC. And it deploys the control plane, it deploys the workers, it connects them together, and it deploys components inside the Kubernetes that I think most people will find useful, like, for example, ingress and certificates and so on. And the production-ready profile even adds backups on the S3. It adds storage for persistent volumes inside the Kubernetes. And it's all built on the Docker VM types. So it's kind of persistent, although still Kubernetes, still Zerops platform. So you should expect any single instance to be ephemeral.
Thank you, Jan. And what are the 3 Kubernetes profiles?
So from my experience, everyone who uses Kubernetes needs different kinds of things. And there's a lot of kinds of usage. You can have just a cluster to develop things, to test out how it works. You can have a cluster that's for production, but it doesn't need to pay for the full, highly available Kubernetes things. That's pretty heavyweight. Or you can want the heavyweight thing to ensure that you will never ever go down, no matter what happens, basically. So that's the 3 profiles I built. The staging or development one, it's just one control plane, one worker, as simple as it can possibly be. It has traffic as ingress. There's no storage because it doesn't make sense to create a storage that would be persistent if you have only one worker that can go down at any time. And it would just eat up your resources. There's no observability built into it. This is playground for you. And it isn't, of course, CNCF compliant fully because it doesn't have high availability of anything. This is basically to get you started with running Kubernetes on Zerops and to deploy the most primitive of applications to just check if it works. Then there's the production. It still has only one control plane, because if control plane goes down, it just means you can't change anything inside the cluster, but all the workload that's already running there, the storage, everything works. So it's just, you cannot control it. So for production, I don't think you need highly available control plane, but you already have 2 workers or more. You can definitely scale this wide if you want, or up if that's what you need. It still has traffic because it's very, very lightweight and it's easy to use for most developers. And it already has storage. So there's a Longhorn with 2 replicas inside it. So whatever you need to persist, you can simply just create a PVC like you would in any kind of Kubernetes that's managed by EKS or something like that. And it's already partly compliant with the CNCF conformants, just with their quick version for clusters like these. And then there's the full profile, which means you basically want everything you could need. So there's 3 control planes and 3 workers to start with, but again, you can scale to whatever size you need. The platform supports it and pretty fast as well. For ingress, you've got the gateway API instead of traffic, because that's the new way how Kubernetes clusters are built since the Nginx ingress has gone away. It's no longer supported. And it's a little more complicated than traffic is, but then again, you can do basically anything. It can do anything you would want about load balancing or routing your traffic in the cluster. And there's also Istio as part of the cluster, which means that inside the cluster traffic is completely encrypted. You don't have to worry about bleeding your information anywhere. So this is for you if you don't trust Zerops platform and the Zerops L2 isolation in the project. You can completely hide your traffic away from us. Longhorn is there again, and you can in this profile actually encrypt it. So again, even if we from Zerops wanted to, we cannot get to your data. Just remember, don't keep the key on the platform. And there's full observability stack. There's Prometheus with Grafana. There's Elk with APM. There's Alloy. There's FluentBit. So every piece of information from the whole cluster that you could ever need flows into your dashboard. That's again part of the Zerops. If you want to direct it somewhere off-platform, which can be a viable course of action, of course, it's possible. It's just one switch in the deployment, and that's it.
Thank you, Jan. I think this really shows what real transparency is. I think the real transparency is that when you say don't trust us, I also say that like don't trust everything I say. Go and check that. I think this is the best you can expect from someone who is giving you some ideas and some concepts. And now I know what you might be thinking, because as developers, we like to start small. We like to start with a hello world, and so someone might think, but why do we need the 3 profiles? Is that too much? Can't we have just one single profile and one single configuration? Why do we need 3? Do we really need the 3? This is a question that someone might have.
That depends on the shape of what you are running, basically. So if you really don't care about availability or anything, you can just run it in the most simple way, even if it's production. Because if you have an app that's just your personal calendar or something like that, you don't need to pay for the full stack and encrypt everything and stuff like that. And on the other side, if you are a startup in fintech sector, you definitely don't want to trust anybody, like anybody. So that's what the full profile is for.
Thank you, Jan. And now something that I'm really curious about. What made this technically possible on Zerops? So how was it possible? Because I haven't seen this much around.
So there are basically 2 enablers for running Kubernetes on Zerops. One is the L2 network that you can fully control. You can use VRRP packets. You could actually even use BGP inside it if you wanted, or CARP, basically any kind of mechanism to switch IPs fully under your control from a box to another box, which allows you to run basically any kind of networking inside it that you want, which is what most platforms don't do. They connect things in a mesh with WireGuard or something like Istio, or basically any kind of these solutions which don't allow you any kind of control over the network. Therefore, you cannot run Kubernetes there because it needs to control its own network, at least to some degree. And the other is the full KVM VM you can get, because that's what you need to run Kubernetes. It's of course possible to do things like Kubernetes in a Docker or Kubernetes in Kubernetes and stuff like that, but it eats away your performance, and these little bugs keep appearing everywhere because just version of one layer is slightly different than the version the other layer expects, and they don't interconnect very well. But if you get full Linux, full VM, that's what Kubernetes is made to run on. So that's what you want.
Yes, thank you. And I think that the point here is not that every Zerops user should deploy Kubernetes on their own, but the point is that the platform Zerops did not prevent a complex system like Kubernetes from being built. And this experiment really turns Zerops is flexible from a marketing claim into something that developers can really inspect and verify. And this is really transparent, and this is also reflected on all the features you have. I don't know, we have now ZCP, Zerops control plane. You can see everything inside it. You can inspect. You have the logs. This is a real pleasant experience, let's say, as a user. So I think this is a great advantage. So, Jan, we built a Kubernetes template receipt that developers can use, right?
Yes, we did. And we did that using inbuilt ZCP component of Zerops, which is basically an AI harness that allows you to put Codex or Cloud Code or Anti-Gravity or Grok inside it, whatever is your preference, and control your project, only a single project, not your organization, not everything, just a single project to make it safe, to reduce the blast radius in agentic way. So ZCP is in its core an MCP server with some skill harness around it. That's why you can use basically any kind of agent you prefer. You can use it completely within the platform, or you can initiate it from your workstation. And I've wanted to test its limits, basically, because building a CNCF conformant Kubernetes is not an easy task. It's something that, for example, Gemini 3 would completely fail at. Even Grok would be very hard pressed to do it. On the other hand, in the past, Opus 4.8 could do it with a lot of tokens spent. And I've decided to do this very shortly after OpenAI released GPT 5.6. So I've installed the ZCP. I've put in only codecs, nothing else with Sol, and I've given it maybe 600 words of instruction as a first prompt. I didn't heard it in like how it should do the things. I only prompted what is the expected result I want from it. So it was the goal for it was to build a GitHub repository that has 3 profiles for Kubernetes inside it. I've described how each profile should look, what components it should be comprised of, and that it should be built in a highly available mode, because that's what models like to forget. And I've set it out, basically. So it worked for like about 4 days straight without much interaction with me, after asking me a lot of initial questions, of course. And it made a few mistakes along the way, which weren't, for me as a DevOps engineer in past, very complicated to remedy. I think even developers who don't have experience with infrastructure could do it, because it was basically just a error in judgment of how to build highly available IP addresses. So it was using basically just DNS-based system, which is known to break and known to take long to change the address into different node. So Sol kinda surprised me there. I wasn't expecting this of it, because the previous versions of OpenAI were lagging in terms of infrastructure work, but the Sol basically nailed it. I only had to spend like 4 hours at total touching it and just guiding it slightly. But it was working on its own. It built everything, it tested everything. It redeployed every single profile twice just to be sure. So pretty good job there from OpenAI and from ZCP, because I think that's the important part, that the agent knows the context of the platform. And that's how you should use platforms, in my opinion. The platform should give you, or your agent more like, the context of how it should be used, and what are the golden paths on it, and what are the entire width of possibilities on it, and then let the agent use its intelligence to use that.
Thank you. This is very nice to hear. So congratulations to the OpenAI team, of course. So now we have a benchmark. When we want to test a model, build the Kubernetes on Zerops, and if it works, it seems that the model is good enough. Nice. And also, I would say 4 days, it's not super short, but that's not a Hello World application. So, but it's not that super long. I've heard like projects running for way, way longer. Good job, really. I have a couple of questions, because this got me really curious. Do you remember the hardest problem that the agent encountered?
I think the hardest problem in terms of how long it spent on it was to get the cluster from the state where it was running with all the services to the state where it was actually CNCF conformant, because that's not an easy benchmark. There's a lot of rules that the Kubernetes cluster needs to have. On the other hand, it's a pretty good thing to give us a goal to agent, because it's very deterministic. It needs to run the full test, and it knows that if it doesn't get all the green ticks, it's failed. And so it goes again and again and again. So I think that was hardest for the model to do.
And Jan, one more question is, what is something that surprised you in this process? Because this process is surprising already, but is there anything specific that surprised you? You had like a wow moment during this process?
Definitely. It was when the agent using the ZCP managed to find a component of Zerops I didn't know existed. So in the past time, before Zerops introduced load balancing through Nginx, there was load balancing done only on the IP, on the TCP level through DSR. And it still remains there. So it's available for anyone. And I didn't know about it since I wasn't in Zerops from the beginning. And the agent found it and decided it's a pretty good way to ensure high availability of its inbuilt load balancing, which I then have told it not to do and to install the VRRP instead, which is more reliable. But it still was a pretty surprising moment when I was like, there isn't any load balancing done. How the hell is it working when I shut the node down? How did it jump to the second one? There's nothing on the platform that should do this. And the agent was, of course, there is something. There's DSR. It's documented here, here, and here.
Okay, that was funny. Now, one last question about this topic, which I think is super interesting. How much human guidance was required when the agent encountered these failures? Because I think this is now the most important skill, understanding what the AI is building and having, of course, some knowledge to guide these agents.
So the guidance was still definitely necessary. It still made some errors in judgment, and it still required human touch to basically decide how to approach them, because it had the right it had the right ideas about how to fix it. But if it was like trying all of them and testing all of them, it would take far more time than 4 days to develop the whole thing. I've spent like 4 hours on guiding it throughout the 4 days period. So I would say not much guidance was required, but still you need to make the decisions. You need to understand the components that it's using. If I didn't know what's a proxy, if I didn't know what's Istio, if I didn't know what DSR is, I would be pretty lost in how to guide it, and it could make a lot of erroneous judgment how to implement the components.
Thank you, Jan. This has been very interesting because, of course, we can learn more about Zerops AI, the potential of AI models, and also a bit about how Zerops is done, that I think is something very fascinating and unique, I would say. So thank you so much for your knowledge and for sharing with us your experience. Really surprised about OpenAI, by the way, so good job to the team. And thank you. And see you probably in some next episodes. Thank you.
Thank you. Bye, everybody.